Welcome one and all to the lesson video focusing on trig functions. Here, you're going to learn how to identify the values of the 6 trigonometric functions of an angle. Now to get started, we need to quickly review the Pythagorean theorem, which focuses on right triangles. The formula is a squared plus b squared equals c squared, where a and b are the two sides, and hypotenuse is c. With trig functions though, we're not going to use a, b, and c. We're going to put it in terms of x, y, and r, where x and y is the point on the terminal side of an angle given on the graph, and r is the distance between the origin and the point given to us, which essentially is the hypotenuse when you form a right triangle with the given point. So as you can clearly see on the image, there's a right triangle that will be formed with x, y, and r. Big thing to note is that r will always be bigger than 0. Okay? It will be positive because it is a distance that cannot be listed as a negative number. These are 3 trig functions you should already be familiar with: sine, cosine, and tangent. As you may have learned it as SOHCAHTOA, where its sine is opposite over hypotenuse, and so on and so forth. However, again, we need to establish it in terms of x, y, and r. So sine is technically y over r, cosine theta is x over r, and tangent theta is equal to y over x, where x cannot be equal to 0 or else it would be undefined. These, however, are 3 new trig functions that you will learn, which is cosecant, secant, and cotangent. Cosecant is equal to r over y, which is the hypotenuse over opposite. Secant is r over x, and cotangent is x over y, where again the denominator cannot be equal to 0. If we were to put it all together though, what do you notice? There should be a special relationship you should see between the trig functions. The hint is the color coding. And there it is. Each horizontal pair of trig functions are reciprocals of each other, so the reciprocal identities, where sine is equal to 1 over cosecant, and cosecant is equal to 1 over sine. If you forgot what a reciprocal is, it is literally flipping the fraction. Cosine is paired with secant, tangent is paired with cotangent. I did note that each pair has a single co-trig function. So when you look at sine and cosecant, it's cosecant. Cosine and secant are a pair, and tangent and cotangent are a pair. So that's how you can kind of easily identify which pair goes with which. So now let's dive right into finding the values of the trig functions given a point on a graph. So we are given 3 and 4. Well, that means that x is equal to 3 and y is equal to 4. But in order to find r though, this is where the Pythagorean theorem kicks in, and you say, alright, what is 3 squared plus 4 squared equal, sorry about that, 3 squared plus 4 squared equals r squared. And you say, alright, let's evaluate it. 3 squared plus 4 squared is equal to 25, equal to r squared. But you have to take the square root of both sides in order to solve for r. So if you do that, 25 is a perfect square, so therefore 5 is equal to r. But please understand, this is not our final answer. This is what we needed to do to find the final piece. So now that we established what x, y, and r is, we can now plug in and find the values of each trig function. So sine is y over r, which is 4 over 5. But if sine is 4 over 5, then cosecant is the reciprocal of it, then it would be 5 over 4. Cosecant is the x over r, sorry, not cosecant, cosine is x over r, so this time it's going to be 3 over 5. And secant is the reciprocal of it, so it's going to be 5 over 3. Tangent is y over x. Apologies as I was fixing that. So it's going to be 4 over 3. And cotangent is the reciprocal, so therefore it's going to be 3 over 4. Last thing you do is you check to make sure you can't simplify any of these fractions, and you can't, so therefore we're good to go. Typically, quadrant 1 is the easiest area of the graph to focus on, and easily to find the trig function values. So now let's go to quadrant 2. So this one is where I'm going to start laying out the work already beforehand, and we're going to walk through each step. So here you're given negative 5 and 12. Negative 5 is clearly my x-coordinate, that's on the left side of the graph, and 12 is the positive region, which is above the graph. So therefore we're on quadrant 2. If you use those two numbers and plug in, use the Pythagorean theorem, you find that your r is equal to 13. Then you take those three numbers, plug in the trig values, and you check to see, can I simplify anything? No. However, we have negative numbers involved. So notice which trig functions are positive and which trig functions are negative. This will come into play later in the video. Now quadrant 3 is where you have both x and y being negative numbers. Now this problem is the hardest one because now we establish that r is not a perfect, it's not a whole number, it's going to be a non-perfect square root. If that's the situation, then you're going to have some problems where when you plug in the numbers into the trig values, you have a couple fractions where the denominator has a square root, which is a rule we clearly established earlier in the year, where we never have a square root in the denominator. So you have to rationalize it. You multiply both top and bottom by the square root. So sine's final answer is negative 6 square root 37 over 37. And then cosine's final answer is negative square root of 37 over 37. A couple other things to note is that for tangent and cotangent, when you have both a negative number over a negative number, you can just evaluate it as a positive value. You still reduce it wherever you can. The last thing I will note is that secant says square root of 37 over negative 1. Well, anything over 1 is itself, but because it's a negative, it's going to be negative square root of 37. Again, take note of which trig values were positive, which trig values were negative. Positive versus negative. The last one is quadrant 4, where x is positive but y is negative. I went back to an easy one where r is equal to 17. Plug in the numbers, you have your values, can't reduce anything, so therefore you are done. Now, going back to the questions I asked earlier, I told you to identify which trig values were positive and which trig values were negative. Well, you're going to notice that depending on which quadrant you're in, certain trig values will be positive and certain trig values will be negative. Now, quadrant 1 is the easiest, I said, because everything is just positive, so you don't even have to worry about that. If you look at quadrant 2, only sine and its reciprocal of cosecant are positive. Quadrant 3 is where tangent and the reciprocal of cotangent are positive, and quadrant 4 is where its cosine and secant are positive. So this chart is for you to have as a resource. However, I would also recommend the graph form, and this is probably the nicer one because you can actually visually see on a graph as well. So as we established, quadrant 1 is where all are positive. Quadrant 2 is only where the sine, which is reciprocal cosecant, is also positive. Quadrant 3 is tangent, quadrant 4 is cosine. And I made this acronym though to help you remember. A smart trig class, where A is the all, S is smart for sine, T is trig for tangent, and class for cosine. So it's in the same order of which quadrant it corresponds with. This is going to be important for questions like here, where you are going to be given certain parameters and you need to identify which quadrant the angle theta would lie in. So let's go ahead and try to figure this problem out together. You are told that sine theta is less than 0, which is just another way of saying that sine is negative. So if sine is negative, we can clearly eliminate quadrant 2, because quadrant 2 is where sine has to be positive, and we can eliminate quadrant 1 where everything is positive. So we have to choose between 3 and 4. So now we look at the second parameter and we say, hey, secant is greater than 0. Now, secant is the reciprocal of cosine. So if cosine is positive, therefore, we've established that it has to be quadrant 4. And therefore, that will be the final answer to a problem like this. Sometimes it may not sometimes it may require you to eliminate just down to one choice left over. Sometimes they may give you the piece itself to just identify which is true or not. And that's all there is to it to this lesson, ladies and gentlemen.